Okay, 6.5 part 3 is parallel vectors. And so it tells us that two vectors v and w are parallel if there is a non-zero scalar c, so that vector v is equal to c times w. The angle theta between parallel vectors is either going to be 0 or it's 180 degrees. And so vector v and vector w are parallel if v dot w is equal to plus or minus the magnitude of v times the magnitude of w. So let's look at example 1 here. It says determine whether the vectors v is equal to 2i minus 3j and vector w is equal to negative 4i plus 6j are parallel. Alright, so one thing we can notice is look at vector w. On vector w, that negative 4i plus 6j has the greatest common factor, and that's of negative 2. So if I factor out that negative 2, I'm left with 2i plus 3j. But wait, 2i plus 3j, that's vector v, isn't it? So this is equal to negative 2 times vector v, which tells us by the definition above, since v is equal to some scalar, c, which in this case is negative 2, times w, or we could say w is equal to a scalar times v, then we know that they're going to be parallel. But we need to prove it. So how are we going to do that? Well, we can find their angle. Remember, if their angle is 0 or 180 degrees, then it's parallel. So how could we find that angle? Well, just like what we did in part 2. We know the formula that cosine of theta is equal to v dot w over the magnitude of vector v times the magnitude of vector w. So let's find that angle. So cosine of theta is equal to vector v is 2i minus 3j, and dot vector w is negative 4i plus 6j over the magnitude of vector v, which was 2i minus 3j, times the magnitude of vector w, which is the negative 4i plus 6j. That should be more straight. Alright, so I'm just going to slowly work through this one. So I'm going to write the top as the vector component, So we got 2, vector v is got components of 2, negative 3, dot, vector w's components of negative 4, 6, over, and I'm going to use the formula for the magnitude. So for the magnitude of v, we're going to have the square root of 2 squared plus negative 3 squared times the magnitude of vector w, which is a square root of negative 4 squared plus 6 squared. So we get cosine of theta equals, in the numerator, because we're doing the dot product, remember, multiply the first two components plus the multiplication of the second two components. Over, I know this is really close there. On the bottom, in the denominator there, we got 2 squared, which is, or square root of 2 squared, which is 4, plus negative 3 squared, which is 9, times the square root, negative 4 squared is 16, plus 6 squared is 36. So we have cosine of theta equals, in the numerator, 2 times negative 4 is negative 8, plus negative 3 times 6 is negative 18, over, in the denominator, we have the square root of 13, times the square root of 52, so if I keep going, in my numerator, I have negative 26, over. Now, in the denominator, we could try to multiply those together and then factor it out to see if we can do square root, but that's going to be a really big number. But I think that 52 is divisible by 13, so I'm going to come up here and I'm going to factor out that 52. So the square root of 52 is what? 2 times 26, which is 2, 2, and 13. So it's 2 square root of 13. So we have the square root of 13 times 2 square roots of 13. So I have negative 26 over, we're going to have to work in that denominator. Remember, when you're multiplying with radicals, you multiply the numbers on the outside. So I've got a 1 in this first one and a 2 in the second one. So 1 times 2 is 2. And then you multiply the radical, what's underneath the radicals together. So I have the square root of 13 times the square root of 13, which is just 13. And so we have that cosine of theta is equal to negative 26 over positive 26. So cosine of theta is equal to negative 1. Now we could still use our calculators, or think about this. You know about if it's a whole number on your unit circle, okay? So either way, remember, when you're looking for the angle, you're going to use the inverse cosine. But before you actually throw this in your calculator, guys, just think. You're looking for a cosine of an angle that gives you negative 1. So if you're thinking about your ordered pairs when you did your unit circle, cosine is what? X or Y? It's the x value. And where is x equal to negative 1? Right there. So theta is equal to 180 degrees, or you could have said pi. Either way, if that angle is 180 degrees or 0, remember, if it's either one of them, then that means that these two vectors are parallel. So you've proven it.